The next transformation we're going to talk about are dilations. And dilations we might also refer to as stretches and compressions. And kind of like the horizontal translations, sometimes this seems to be a little bit counterintuitive. Um, and let me just approach this first one here, this 2x squared. Now, x squared, that's the parent function. That's a quadratic. And this 2 out here, this coefficient in front of the 2 is going to cause a dilation. And when that coefficient is greater than 1, it causes the graph to be stretched vertically. Now, let's say, for instance, we got a quadratic and it's got a U shape like this. Not too pretty, but whatever. The translation is actually going to be, look, something, well, that's a V-shaped. Let me just erase this whole thing. So our parent function looks like this, and our translation looks maybe something like that, except more of a point down there. And that doesn't necessarily seem, in my mind at least, to be a stretch. And so what you need to think about is if I had a rubber band and it was cut, and I were to pull up vertically on the ends, that rubber band the ends would come closer together. It's being stretched vertically. And we'll see how that performs here on a graph in just a moment. Now this second one, I got the absolute value of 1/3 of x. Well, we know the parent function, if it was just the absolute value of x, is going to be V-shaped, something like this. But this coefficient of 1/3, and it's less than 1 but greater than 0. So if it's greater than 0 but less than 1, it is going to compress the graph, or it's almost like it's taking the ends and pushing it towards the horizontal axis, the x-axis, and so it's going to appear something similar to that. Not exactly, but that's just to kind of give you a visual. So let's jump over here to the graphing calculator. We're going to graph both the parent quadratic function and the equation here that's going to cause a dilation, a stretching vertically. And then we're going to graph the parent absolute value function along with the absolute value of 1/3 x. All right, so again, as promised, we're over here on our graphing calculator, and I'm going to clear out what we got. And I first want to graph the parent function, which is of a quadratic, which is just x squared. And then we're going to graph this transformation, this dilation, as 2x squared. Let's jump over to our graph and see how this appears. So in the blue here is my parent function, and then the red I see coming in, that's my dilation, and it is being stretched vertically. So again, think about if I was holding the ends of the graph in blue and I just pulled upward on that, it would cause that to move closer to the vertical axis, and we call that a stretch, actually. And again, I think, to me, in my mind, this seems to be a little bit counterintuitive. Now let's go do the absolute value function, and there's something important here that you need to get in the habit of doing. All right, again, I'm going to clear out what we got. Well, I didn't clear out what we had. Let's hit the clear. Hit the clear. All right, go back up here to Y1, and we're going to go to math. Move it over to the number. We're going to choose the absolute value. And we're simply going to put in the X and clear the absolute value symbol. And now let's go down and graph the transformation. So again, I'm going to choose math, number, absolute value. And I want to put this 1/3 in parentheses, just maybe as a precaution to make sure my calculator reads this as 1/3 and not 1 divided by 3x. So now I got 1/3 x. This is important. Putting that in parentheses is going to be important. In fact, I may at the end come back and show you what would happen if I didn't. All right, so let's take a look at this graph. My blue is my parent. My red is my dilation, and it is being compressed, if you will. Think about it being pushing down, compressing this towards the x-axis. And so there we got dilation. I want to go back in here just for fun and see what happens if I don't put that 1/3 in parentheses. Let's see what happens. It may not do much since it's absolute value, but we'll find out here in a minute. Choose absolute value, and we're going to go 1 divided by 3 x. Yeah, it didn't do much in that case. Well, what if I just had 1 divided by 3 x? What's that graph going to look like? It's just going to look like a line, isn't it? Interesting. Okay. All right. Well, there we go. Dilations, stretches, and compressions.